Hi, continuing from where we left off last time, let's look at quadratic polynomials. And I have taken this quadratic polynomial x squared minus 4. So if I put different values for x, I have put a few here, minus 3, minus 2, minus 1, 0, 1, 2, 3. If I put minus 3, then it becomes f of x is equal to minus 3 whole squared, that becomes 9 minus 4, which is 5. That is what I have put over here. So minus 2, when x is minus 2 whole square, that is 4, 4 minus 4, 0. Now next one, when I put minus 1 whole square, that is 1 minus 4, that is minus 3. And when x is 0, then it remains, the whole polynomial becomes minus 4. When x is 1, again you would see 1 squared minus 4, that is minus 3. Then when x is 2, 2 squared, that is 4, 4 minus 4 is 0. And 3, you can see it's 5. So now let's see how this looks like, how the shape of this one looks like. We saw that a linear polynomial is a straight line, and we saw that the 0 of that was 1. The maximum you can have 1, 0. There is a single case where the number of zeros is 0 in a straight line. See, in a straight line, we saw any straight line. See, any straight line that comes will cut here, one point on the x-axis. However, if suppose there is a straight line which is parallel to the x-axis, that will not cut the x-axis anywhere. Okay, so that is one case where you don't get a 0 of this. Other than that, you will get a 0. So the maximum number of zeros that you can get is equal to the degree of the polynomial. So the degree of that is 1, but so you can get maximum of 1, 0. So in the case where you are not getting a 0, what is that particular case? It will be like f of x is equal to a constant, suppose 2. Then that means that it is x to the power 0. So this 2, so here it will be cutting the y-axis at, or the f of x at 2. So and it remains 2. The value, whatever be the value of x, the f of x value is always 2. Since the degree is 0, so x to the power 0 is 1. Keep that in mind. Now in this particular case of a quadratic polynomial, in a quadratic polynomial, here what do I see? I see that, let's plot these points, 1, 2, 3, 4, 5, 6, 1, 2, 3, 5, 6, 1, 2, 3, 1, 2, 3, 4, 5, 6. So this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 1, minus 2, minus 3, minus 4, 5 and minus 6. And then let's plot these points. Minus 3, 5. Minus 3, 5. Minus 2, 0. That is this point. Then minus 1, minus 3. That is over here. And then 0, minus 4. Similarly, if you come here, this minus 1, so this minus 1, 3 here. And then same way, this side 1, minus 3. Then 2, 0, 3, 5. So it looks like this. This shape is what you call a parabola. And you see this cuts the x-axis at 2 points. So here the degree of the polynomial is 2 and it cuts the x-axis at 2 points. What is the meaning of that? So when at this point, when x is minus 2, the f of x value is 0. So you have two zeros, minus 2 and 2 are the zeros of this polynomial. So there can be other cases. Suppose this curve, this is here, or it is here. It just touches. What does that mean? That means that both the zeros are at the same place. And sometimes you may have it like this or like this, in which case it is not touching the x-axis at all. So then we say that the zeros are imaginary. We don't have real solutions or real roots. So that is for your understanding that I am telling this. But we will go forward and we will see what is the relationship between the zeros and the coefficients of any quadratic polynomial. This part is a part you need to listen very carefully, since many questions are going to come from this. So general form of a quadratic polynomial is ax squared plus bx plus c. Now, in a quadratic polynomial, suppose alpha is one of the zeros, then I can say x minus alpha is a factor of this polynomial. Similarly, if beta is another zero, then x minus beta is also a factor. Now so there can only be maximum two zeros, as we have seen. So I can write this as ax squared plus bx plus c is equal to x minus alpha into x minus beta into a constant k. There may be a constant, because otherwise x into x squared, but this has a coefficient a. So what is that coefficient? We don't know. So there should be some constant also. So there is a k that I am putting over here. So now if I were to multiply on the right hand side and expand it out, I will get k into x squared minus alpha x minus beta x plus alpha beta. And doing it further, I can take it as kx squared, and these both are together, so I can write it as minus, take the k from inside, and x and k, I can write it as alpha plus beta into x plus k into alpha into beta. And this side, on the left hand side, you have ax squared plus bx plus c. Now if you look at both the sides, you will see that there is a x squared term here and there is a x squared term here. There is a x term here and there is a x term here, and there is a constant here, there is a constant here. We can equate each of these to each other, and then I have ax squared is equal to kx squared. The x squared goes, that means a is equal to k, or I can say k is equal to a. Next, I have bx equals minus k into alpha plus beta into x. Then I cancel the x out and I get b is equal to minus, instead of k I am going to substitute a. So minus a into alpha plus beta, or I can say alpha plus beta is equal to minus b by a. If I take the minus this side, it becomes minus b by a. The a comes down, so alpha plus beta is equal to minus b by a. So what is alpha and beta? They are the sum of the zeros. So sum of the zeros is equal to minus b by a. What is b? B is the coefficient of x and a is the coefficient of x squared. This is the relationship. This is that you need to keep in mind. There's one more thing that we still have. The last term, the constant term, that is alpha, that is C is equal to K alpha beta. K is A, so I can write it as C is equal to A alpha beta. So C is equal to A alpha beta, bringing the A down, I can write it as C by A is equal to alpha beta, or alpha beta is equal to C by A. Now I can say, what is alpha beta? That is a product of the roots. So I can say product of the roots is equal to C by A. C is a constant by coefficient of the x squared. Sorry, product of the roots is equal to C by A. So you need to keep this in mind. Sum of the zeros is equal to minus B by A, and product of the roots is equal to C by A. Now let us do a problem using this. So the question is, find the zeros of the polynomial x squared plus 7x plus 10 and verify the relationship between the zeros and the coefficients. Now, in this is of the form ax squared plus bx plus c. So what is a here? There is nothing in front of x squared. Many students do this mistake of saying now a is equal to 0, or some of them say a is equal to x squared, but a is neither 0 or x squared. A is the coefficient of x squared, and if there is nothing in front of x squared, it means there is a 1. So a is equal to 1, b equals 7 and c equals 10. So if there was a negative minus sign here, then b would have been minus 7. So it is very important to take the sign also. Now they are asking us first to find the zeros of this polynomial. So how do you find the zeros of the polynomial? X squared plus 7x plus 10. So this is a quadratic polynomial, and if you remember the method of splitting the middle term. So for those who don't remember, please listen carefully over here. Now a is equal to 1, b is equal to 7, c is equal to 10. So what you need to do is take AC and b. What is a into c? 1 into 10. That is nothing but 10. And what is b? b is 7. The way to do this is, you have to find two numbers such that when I multiply those two numbers, I get a 10, and when I add those very same numbers, I should get 7. So what are the possibilities? I can get multiply 10 into 1, but then 10 plus 1 is not 7. What about 5 into 2? 5 into 2 is 10. 5 plus 2 is 7. So perfect. So we have landed upon the right numbers. So 5 plus 2 is 7 and 5 into 2 is 10. So this 5 plus 2, so you see that the middle term is 7x. So this 7 has to be split into 5 and 2, or the 7x can be written as 5x plus 2x plus 10. Now take these first two terms after this. The splitting is a key thing. You have to make sure you get the right numbers. So then x squared plus 5x, take the first two terms. What is common over here? As we see, x is common. Then x into x plus 5 plus, you put the very same x plus 5 over here. Now see this, what is the next term over here? 2x. what should I multiply with x to get 2x plus 2? So put plus 2. 2 into x, 2x. Now let's do our check. 2 into 5, 10. Perfect. So we have hit upon the right number over here. So now x plus 5 is common in both these terms. So I can write it as x plus 5 and it is into x plus 2. So what are the zeros now? X plus 5 can be 0. So that means x is equal to minus 5, or x plus 2 can be 0, which means x is equal to minus 2. So that means alpha, the first 0 is minus 5 and beta is equal to minus 2. Now after this you have to verify. They have asked us that we should verify the relationship between the coefficients and the zeros. So what is the relationship? Alpha plus beta is equal to minus b by a. And the other relationship we need to verify is alpha beta is equal to c by a. So let's take the first one. So in this left hand side, alpha plus beta. What is alpha plus beta? Minus 5 minus 2, which is equal to minus 7. And minus b by a. Minus b by a, RHS is minus b by a, which is minus b is minus 7 by a is 1, which is minus 7. So therefore alpha plus beta is equal to minus b by a. Perfect. We have verified the first one. What about the second one? Alpha beta. What is alpha beta? Minus 5 into minus 2, which is 10. And c by a. What is c? 10 by 1, which is equal to 10. So you have alpha beta is equal to c by a. So this is the way that you will verify the relationship between the coefficients and the zeros. So I hope this is clear. The method in which you do this is clear. But the key thing to remember is that you need to know the splitting, the middle term method of factorization quite well, and then you need to remember this alpha plus beta and alpha beta. So in our next session I will look at the cubic polynomial and the relationships, and we'll also do some polynomial long division, so that some of you might have forgotten that, but it's important that we remember it again. Okay, so please try the problems in your books, and if you have any doubts, please get back to me. Thank you. Bye.